Right. Thank you very much, everybody. Thank you very much, Herman. Sorry, my pronunciation is terrible.
No worries.
Anyway, thank you. Right, so when the cloud's reign is over, before I begin, I'd like to have a quick show of hands of. So, who do you here? Do you have ops? Anybody? Ops people? 1, 2, 3, kind of, maybe, not quite sure. Dev? Sysadmin? Oh, you seem to have a decent spattering. Fair enough. Okay. I'd just like to know roughly who we're talking to so we can tailor the talk slightly. So before I begin, I'd like to say a big thank you, first of all, to CodeSync for making it possible for me to be here today. Same as much to TI Tokyo, my company, for letting me to come here today. And I thought we'd like to go through what we're going to talk about before we go further. So in today's session, we'll be having a brief introduction. We'll be talking about early cloud days. We'll be going on to talk about whose cloud is it anyway. Talk a little bit more of what is actually going on in the corporate side of this thing. Why does it work the way it does? And then we'll finally wrap up with a brief Q&A session. So, an introduction. Who am I? Why am I talking to you? Why should I talk to you about this? I mean, I'm the head of IT support at TI Tokyo. I'm a 27 veteran of tech supports. I've been in all different kinds of IT. Part of that, I've supported React for 6 years. So people may be thinking, well, why cloud? Yeah, React works in the cloud, but that's not the real one here. But we'll come to that later. I contribute to the React open source project, and possibly the most important one, I've worked in most IT different roles. Dev, DevOps, sysadmin, you name it, I've probably done it. And that includes both cloud and data center infrastructure. So going on, before I jump into it, a brief disclaimer. Despite what I say in this talk, cloud is not all bad, especially if you're small. For small companies looking to grow rapidly, cloud is awesome. Please remember that before I go into the rest, because otherwise you might get the wrong impression. So, early cloud days. How many people here remember life before the cloud? A fair share. Nice. Good. Okay. I remember my first cloud conversation. It was with my boss. So I was sitting there working quite happily, and my boss sauntered in, as he often did. Comes out and says, "Hey, Nick, what you doing?" "I'm working on the web server." "Yeah? Where's that?" "It's in the data center." "So why do we put all that stuff in the cloud?" "Why?" "Because it's cool. I mean, it's cloud, it's new, it's cool, it's exciting. We'll make this happen." "Why? Why would I want to put it on just somebody else's computer?" "Because it's cool, man. It's the next thing." And this continued. So his main argument was, it's cool, we should do it. You know, it's more secure. But I control the security. If I set it up, it's as secure as I make it, be it here, be it in a data center somewhere else, be it on the cloud. It's the same. I control it. It's not more secure at all. But, you know, it must be faster. Yeah, it's definitely faster. You're telling me that we have a data center in Japan serving Japanese customers, and you want me to put this on somebody else's computer in America so all our customers can travel across the Pacific to get their data, and then that data can come all the way back to Japan, and that'll make it faster? Yeah, well, it's something I'm thinking on, you know. It's going to be good at some point. And to be fair, he was kind of right. Cloud did get better. But not straight away. I mean, that conversation was from the early 2000s. But then we went on, jumping forward about 10 years here, when I started doing React stuff. One of our big customers had a migration. Basically, after Basho folded, they got scared. They were worried that their data would be lost. So they ran away. Like many people did. Basho is gone. Oh no, it's going open source. What should we do? Run, choose some other platform. So they did. These are people who were huge. They had petabytes of data. That's in, you know, what, maybe 7 years ago or so? No, 6, 7 years ago, which is still quite considerable. I mean, they had over 300 servers, and they were running React CS on top of KV to store, basically offer cloud storage to all their customers. And I thought, well, yeah, we want to move to cloud. You know, why should we have this product that served us really, really well for 8 years when we can move to cloud? Let somebody else do it for us. But you said, well, are you sure your data is going to be safe? Yeah, it's definitely going to be safe. And we looked at their contract, and certain enough, their cloud company, who I shall not name, said, we guarantee the safety of up to 99.9% of all our clients' data. Look at that closely. There's a fascinating bit of punctuation. Our clients' data, 99.9% of all their clients' data on the entire planet. So at this point, they're doing exabytes, maybe even zettabytes of data. And our customers thinking 99% of our petabytes of data are fine. Yeah, right. 0.01% means your data's gone if something goes wrong, and your cloud provider has no responsibility whatsoever for it. So that went well. But moving on, cloud has got better since. But after all, whose cloud is it anyway? As cloud has gone on, there have become multiple different types which people regard in different ways. First of all, there is the most common one, public cloud. This is commonly used when people want to grow rapidly. It's basically you buy into little bits of infrastructure within the cloud network where you're sharing your cloud, the back-end processing with many different third parties. You're literally just sharing a small bit of somebody else's box, which I always think of as somebody else's computer, because that's essentially what it is, just a big one. From there, we then have virtual private cloud, which is when you want to be a bit bigger. You want to guarantee those resources are always available to you. So what do? You say, well, I want to rent all this infrastructure, which is essentially somebody else's computer that I rent all of. From there, we went on. We have the traditional data center, which is now called on-premises, or as everything has to be called cloud, it's now private cloud. And that one there is pretty much my computer that I treat like somebody else's, because that's essentially what cloud is. It's always somebody else's computer, whether it's mine, theirs, or a third party's. It's someone else's computer. And then when we thought, well, what do we do if we have stress selling, where we want to have some things here and some things over there, in-house, off-house, and we call that hybrid cloud, or somebody else's computer bolted onto mine, which is essentially what it is at the end of the day. It's your stuff and their stuff, and it kind of works together if you're lucky. So, with all these wonderful different types of cloud and ways to put them together, how exactly can you use them? So, we have people who use it for rapid deployments. Basically, you need something now, it needs to work quickly, and that's great for dev if you want to test something. Does this really work? And also for operations of, I need to scale my stuff quickly because there's a big spike in data and I'm running into trouble if I don't. We then have, again, the scalability, which is, again, much like I said, we need to scale quickly, we need to grow, and also long-term growth. You need to go from maybe a certain size box to slowly graduate to bigger and bigger boxes as you get more customers, more data, etc. So progressive growth and scalability is very useful. Another reason for choosing cloud is space saving. This may sound strange at first, but think about it. If you are having to rent out large amounts of space to put servers and racks and switches and all the rest of it, that's actually quite a bit of space you're taking up. If you're short on real estate, or at least real estate that's easily accessible, putting stuff in the cloud is actually very space saving. There's also the security side of it. This one here is very much taken with a pinch of salt. So on one side, there's the security part of, well, if you have a dedicated data center, somebody could actually break into your data center and access your stuff. Whereas if it's in the cloud, they don't know whether it's, East Coast states, West Coast of the states, some other country. It's much harder to track down it is. So a data center break-in is not quite as dangerous. But on the flip side, you're more likely to be hacked than broken into, in which case it becomes a bit of a toss-up, really, doesn't it? I mean, Jason Stump, CIO from Wynn Resort, says, regarding cloud security, it depends on the security posture of the organization. If you have a really good security team, your cloud stuff is going to be really secure, whether it's in your own data center or somewhere out in the cloud where you don't really know where it is. So security is a bit of a two-sided coin for that one, which does make cloud a little bit more confusing. And then we come on to the remaining one of reliability. People say cloud is reliable, cloud is great. But if we look at the numbers, AWS suffered 27 outages in 2021. Some nice data I sorted. Being in my entire IT career, I haven't had that many outages of stuff that I've looked after. And Amazon, who are meant to be some of the best people in this game, managed that last year. So yeah, well done, that's a good achievement. So maybe cloud isn't quite as ideal as it could be. But let's think a little bit more. Why are other reasons people are using cloud? What is actually going on? And at the end of the day, it's all about the money. At a decent scale, why should you use cloud? Why will many places choose to use cloud to make sure things work? Well, often it's to fill in the management target checkboxes. All managers have a list of checkboxes they're meant to fill in to make sure things work. And if we look at them, what kind of checkboxes do you achieve? And I see these at work as well. So we have obvious ones like reducing headcounts by outsourcing work. If you're paying people salaries to look after servers, that money could surely be used better somewhere else, so let's outsource it. Put it in the cloud, yay. You've cut headcounts, but you still have stuff that works and does what it's meant to. Other ones to do. Reducing internal spending, such as rent for space, hardware, etc. We've seen that, well, that was the one I covered a second ago. And it goes on with things like that. Another one, which is a fun one, is artificially low committed cloud spending looks better than actual money spent. When you use cloud computing, you can say, I want to set my spending as this much, which is fine. But if it looks like you're going to go over that, which the vast majority of companies do, you will then end up with the, I've forgotten the word for it. The spending that you have to do, the kind of extra spending, the additional capacity you have to pull in at the end, which will suddenly bump up your overall spending. So you can set, this is what we're officially going to spend, but once you hit that capacity and go over, you will then have to pay premium rates. But overall, on budget, having a much lower official one looks better and checks the manager's checkbox. But still on the subject of managers and pennies pinched, where does the money actually go? If you're paying for cloud, where does the money go? Well, first of all, you're paying for someone else to hire the staff to run the hardware you're renting. Somebody has to make sure the cloud works. That's what you're paying for. What else are you paying for? You're paying for somebody else to rent or purchase the hardware you are renting. You're starting to see a theme here, aren't you? Isn't this all stuff you could do yourself? You're paying premiums on any usage above your committed cloud spending. Well, we covered that a second ago, so extra money is going there. And on top of that, you're paying a decent profit margin to the cloud companies. Because if they weren't making money for this, why would they do it? Why would they make their hardware available to you if they weren't making money from doing so? And just to add a little bit of salt to a wound we've already got already, on top of it, we then have to pay legal teams for all those wonderful terms and conditions that handle it when your data is stuck in a data center over here or replicated to a data center over there that's not under your control. GDPR, things like that, were always a lot of fun, and that's an additional thing you have to bear in mind when you move everything to cloud computing. So as we can see, the prices of cloud computing can be pretty high, even though it's something that's traditionally done in-house. Now, if we look at this with a case study of Dropbox, Dropbox is quite a fascinating one. Everybody knows them. People with huge amounts of customer data, essentially their online storage. So, in 2015, their cost of revenue was 67%. That basically means that if we take their annual revenue, and then we look at how much of that revenue was spent in the costs to achieve that revenue, that's what their cost of revenue is, which in this case means that 67% of their profits were eaten by the money it cost to generate them. So what they decided to do, they said they'd create an infrastructure optimization initiative, which they started in 2016. And the goal of this was to move all their stuff from public cloud to, as they say, lower cost custom-built infrastructure in co-location facilities. That essentially they decided to take and lease this from themselves. Basically, they moved all the stuff from the cloud to stuff they controlled. They did it in-house. And what did this achieve? Well, by 2017, their cost of revenue had dropped to 33% simply by killing the majority of their cloud presence. That's quite a tidy number. Not only that, but that meant that Dropbox gross revenue margins doubled between 2015 and 2017. If you can double your gross margin revenues, think how happy that makes your shareholders, how much that means that that money can then be reinvested in IT to provide even better services to your customers. I mean, once you get to scale, this is just a no-brainer. It's incredibly powerful. So going forward, I believe what people should actually start to look at is responsible cloud usage. This is something that anybody can do. Even if you're still small scale, you can think about this in advance. But if you're at large scale, look at your cost of revenue and what percentage of that is cloud spending. How much are you actually spending on your cloud stuff? And if it's above 50%, look at repatriation. Repatriation is a fascinating bit of cloud talk. Essentially, it's the idea of bringing it back into your country is the meaning. But in some cases, if your data center is overseas or your cloud is overseas, you are repatriating as you're bringing it back into local stuff, which makes GDPR so much easier. Sorry, personal nightmares. Moving on. So, yes, where was I? Yes, so if you're looking at that, when you're looking at repatriation, this is different ways to do it. One of them could be incremental. Another one could be making reduced cloud spending a KPI of how your company can go forwards. Another one is, if you're still small and growing, make looking at repatriation part of your development program. So of course, once you get to a certain amount of usage, you'll have pretty much fixed load, fixed storage for a certain proportion of your stuff, after which you should be able to bring that in and just leave the rest in the cloud. And therefore, you end up with a hybrid solution, which should cost you a lot more than just keeping the whole thing running, no matter how big the discounts are the cloud providers are offering you for keeping it there. And should you achieve this, you could probably go on to achieve between 33 and 50% savings annually on your cloud bill, which is not something to be scoffed at all. And this is true. I've looked at different research papers on this, and this is true probably about the top 500 large-scale companies in the US could easily achieve this. This is what I found from the research I read through while putting this talk together. But how should you go about it? Well, it really depends on what kind of data you've got. So, for example, if you've got non-structured data, key value, for example, if you just store a bunch of tiny PDFs or maybe some static transaction data, whatever you really use it for, logging data, then maybe look at some kind of KV store. Of course, being a React person, I'm going to strongly recommend React KV. Yay! 3.11 released last week, no, not last week, 2 weeks ago. It's the newest version. OTP 22 and all fun and games like that. It's probably going to be our last KV release before we hit OTP 24. From there, file store, for example, Amazon S3. If you've got lots of data stored in a standard format, you'd probably want to just shift that in-house. I mean, essentially, it's stuff on disk. Shouldn't be that hard for a copy and paste operation, really. But even if you want to keep things like that, then Amazon S3, well, React.CS has a full Amazon S3 interface, so fun and games. And as this was never really publicized much, React.CS 3.101 packages from 17th of October, now also on OTP 22. And another one, structured data. For example, time series. Give notes here. So yes, application metrics, financial data, things like that. They're all good examples of time series. There was a much better example of this in the talk earlier today. And believe it or not, we've dug out React.TS, which has sat in obsolete by itself for ages, and we've also upgraded that. That's now also OTP 22, and packages available from 30th September. So if people want to play, that has new bells, knobs, and whistles, including the ability to now order and sort, which is much more powerful than it was before. So it's all good stuff. Anyway, those are suggestions for repatriation. There are, of course, many other solutions that are available that are perfectly valid. MongoDB, for example, I've completely forgotten the name as my memory is terrible. Just a second. Yep, the time series DB, which we saw earlier. Different ways to bring stuff back. So I think I've got slightly overexcited and run all the way to the end already. So in a quick wrap up in today, we've talked about different types of cloud. We saw them all. Basically, different types of somebody else's computer versus yours. We have a talk about where the money goes, which is quite disturbing when you consider that places like Amazon make 30% profit on their cloud solutions. We talked about a sample case with Dropbox, how they saved ridiculous amounts of monies and kept their shareholders happy. We talked about different ways to look at repatriating your data and bringing it back in-house. And from there, I'd like to move on just before the Q&A. Quick one, if you want to ask me anything, you drop me an email. If you're interested in React, then this is just a quick blatant plug of, please come help us. We need help. We have lots of stuff that needs help. Come help us, please. Do so. And if you fancy trying React for a bit, we have a whole download. We have binaries you can download if you prefer to do that, or you can build from source, or even come and hack stuff about, even help us with the docs, which is always welcome. And that pretty much brings us to the end of my talk. Oh, quick one I forgot to mention. As part of contributing towards React, because we're really doing this from our own penny, we're offering 6 months of free React support to startup companies wanting to use React, and we offer unlimited free support to charities and open source projects also wanting to use React. So if anybody has any of those they'd like to talk to me about, please get in contact and I'd be more than happy to help out. Right, really.
Thank you, Nicholas.
Yes, thank you very much. And we'll pass over to Q&A.
Yeah, okay. So we'll be taking questions. Any takers? Okay. Any takers online? Okay, then hold on.
Thank you for the presentation. Are there any specific services in the cloud that you think you can generally save the most money by moving in-house?
That's a very good question. It really depends on your use case. Storage now is becoming increasingly cheaper, so that may not be the best one, but generally anything you have pretty much a fixed amount of usage for, if your CPU usage is fixed, if your memory usage is fixed, something like that, you could probably bring in-house without too much of a challenge. It's generally items that spike a lot that are much harder to make the calculation for.
Okay, that makes sense. Thank you.
Thank you.
Yeah, something you didn't mention. So yes, you are spending less money using the cloud, not using the cloud. But what about initial investment you need to go out the cloud, because you need to build all this hardware and stuff like this?
Yes, this is a very valid question. Hence, one of the strategies recommended earlier is the ideal way to do this is to plan to repatriate your data at some point. That would give you a minimum cost charge at that point because it's all pre-planned. There will, of course, be the initial expenditure of actually buying the hardware, setting it up, hiring the staff. And that will give you a spike in your spending. But as you saw from the Dropbox example, not only did they manage to cover that expense, but also save money within only a 2-year period.
Okay, thank you for that. We have 2 additional questions online. Give me a second. Okay, since React has been open source, do you enable all features in the open source version?
Yes, everything that was originally only available from the Enterprise Edition is now available. React KV now has the MDC features. React CS now has the supercluster feature, and React TS supports multi-data center as well. So yes, they've all been re-enabled and are fully available in all open source versions since React KV 2.2.6 and React CS 2.1.2.
Okay, thank you. We have another question from David as well. Any information on React Academy as access to that is no longer available?
React Academy is not something we've been looking at. If people are looking at React training, I'd be happy to help out if people can contact me. Alternatively, there's quite a lot of stuff in React Docs which will help you get up and running if you need to.
Okay, thank you, Nicholas. Thank you, David, for the questions. Hold on.
So the cloud have different layers. For example, there is infrastructure as a service sometimes when you don't really need to go with your own servers, your own racks and so on. So you can rent like middle ground of it. Is there any recommendations of like when it is time to invest in your own, or like we've been using SoftLayer, for example, which is a cloud, but not exactly a cloud?
No, I think that's a very valid question. This is one of these ones where there's no magic solution that fits everybody. It's very much down to your use case. But if you start keeping an eye on roughly how much you're performing, how well your servers are performing in the cloud, how much it's actually costing, and then just try and make an estimate of how much it would cost to build the same setup in-house. At some point, you'll find roughly a break-even point. And then from there, you can project out of when it's actually worthwhile to make the switch. I'm sorry if that doesn't really answer your question exactly, as it's very hard to say, well, definitely this point. But if you get somebody who's very good at grinding numbers, then throw the question to them, and I'm sure they could help you find the answer you need.
Okay. Additional questions? Takers online? Nope. Okay, thank you, Nicholas. Then it's a wrap. Let's give him a warm applause.
Thank you very much.